Okay, our final video for systems of equations will be with the process of elimination. This is a very often not forgotten, but it's just not really used very much. However, when your systems are in standard form, which means x and y are on the same side, your coefficients at the end, it's a lot easier to use this method, okay? So I'm going to show you 3 examples and you can use them accordingly. So for the first example, we have x minus y equals 11 and 2x plus y equals 19. When we're using this method, our goal is to cancel out either the x's or the y's. And the way we do this is by having the same coefficient but opposite signs. So like if you see my first step, it says we have opposite coefficients, okay? And kind of canceling them out. So the cancellation happens in step 2 by adding, okay? After we cancel something out, we can solve for the variable and then just plug it into the other one to get the other one, okay? So here's how it works. In this problem, we don't have to do step 1 because you can see here that negative y and positive y are opposites of each other. In other words, this has a negative 1, this has a positive 1. You can put the 1 if you need to. And those are opposite coefficients. So step number 1 is already done for us. So we can jump into step number 2, which would be to add these systems together. In other words, I'm going to add just like I did back in elementary. So x plus 2x is 3x, negative 1y plus 1y. Well, this cancels, so there's nothing there. Bring down the equal sign. 11 plus 19, well, is going to give me 1 plus 9 is 10, carry the 1, so I have 30. Okay, so this right here, this was step number 2, if you want to kind of keep track. Step number 1 was not necessary because we already had opposite coefficients. Okay, then we're going to solve, which is step number 3. So from here, I'm going to solve for x, so I just divide both sides by 3, which leaves me with x is equal to 10. And that was step number 3. So see, we're already almost done with this first problem. The last part is to find the other variables. So we need to find the y that goes with this x. So for step number 4, I take my x and I plug it back into one of the originals. I'm going to go ahead and use the first one. So x minus y equals 11. So this step right here, this is kind of like the substitution method. We just take this value and plug it in. So this is the same as before. So I'm going to say that 10 minus y equals 11. 11. So I'm just plugging in this 10 into the x. And I'm going to solve for y. So here I do minus 10 minus 10. Hopefully you're getting a little bit better at this. This gives me negative y is equal to 11 minus 10 is just 1. Divide by negative 1 to get rid of this negative. Remember that there is an imaginary 1 here. Okay, so y is equal to 1 divided by negative 1 is just negative 1. So my solution for this one, okay, is going to be at x equals 10, so 10, comma, and y equals negative 1. And this again represents the point where these two lines intersect, so where they cross, okay? Let's go ahead and look at another example. This one, like the first one, also has opposite coefficients. If you look at the x's, we have positive 4x and negative 4x. So step number 1, again, we don't have to do because we already have it. So I can jump right into step number 2, which is to add these two things, these two equations. Okay, so 4x minus 4x, well, that's just 0, so I can cross it out. 8y plus 2y, that's 10y. 20 plus negative 30 is going to give me negative 10. Okay, so I'm just adding vertically here. Okay. Then we jump into step number 3, which is the solve part. So I'm going to solve for y here. So to solve for y in this case, I divide both sides by 10 because 10 is the number that's next to y, which gets rid of it. So y is equal to negative 10 divided by 10 is just negative 1. So there's my y. Okay, I'm going to go ahead and do my last step, which is step number 4. Find the other variable. So in this case, I got to find x. So I'll use again the first one, 4x plus 8y is equal to 20. Take my y and plug it into the y value. So I'm going to plug it into this variable. Make sure you don't plug it into the x because this is y. Okay, so I have 4x plus 8, and instead of y, I'm going to use that negative 1 because I want to see what x is equal to when y equals negative 1. Okay, it's equal to 20. I simplify this, so 4x, 8 times negative 1 is negative 8, so minus 8 is equal to 20. And this is a simple two-step equation, so I need to get my x by itself. To do that, I move my 8, so plus 8 plus 8. If you need to put that line, you can. That's an 8. This gets rid of it. I'm left with 4x is equal to 20 plus 8 is just 28. And now I divide by 4. So x is just equal to 28 divided by 4 is just 7. Okay. And I have both variables, so I can write my solution now. Be careful because notice that the first one that we solved for was y, so you do have to make sure you put this in the right order. So we have 7 comma negative 1. Remember, x comes before y, so our solution has to do the same. And that means that at this point, 7, negative 1, these two equations intersect, and that is where they are equal to each other. And I'm going to go ahead and do one more equation. I'm sorry, system of equations. And this one's going to require that step 1 that we kept getting lucky on, the first two. Okay, so step number 1 is to multiply one of these two, or both, it could happen for both, to get similar coefficients. In other words, the same number but opposite signs, the opposite coefficients. So if you look at this, you do have to think a little bit, okay? You have to consider, do I want to cancel the x's or do I want to cancel the y's? I would probably try to go for the x's because notice that 9 and 3 are they're kind of related in a certain way, meaning that 3 times 3 is 9. Okay, so if I were to multiply this entire thing by 3, okay, I would get that actually by negative 3 because we want to make it the opposite. Okay, I would be able to cancel out the x's. So I'm going to do that step over here. I'm going to say negative 3 times this entire thing and see what happens. Okay, so negative 3 times negative 3, that's going to be positive 9x. Negative 3 times 7y is going to be minus 21y. And then finally, negative 3 times negative 16 is positive 48. Okay, so the reason I'm doing this is because now that I rewrote it, rewrote it, I can line this one up underneath it like so. And I can go ahead and do step number 2. In step number 2, we add this, and look, lo and behold, we can cancel our x's here. Okay, so let me go back and say that again, just in case I lost you a little bit. When this happens, okay, we need to multiply one of the equations by a coefficient or a number. Okay, and the reason we're doing this is so that we can cancel either the x or the y. In this case, I went ahead and went for the x only because I know that 3 times 3 is 9, so that's the easiest thing I could think of. If you wanted to cancel the y's, you could also do some kind of multiplication, maybe times negative 5 by negative 7. So the idea is to multiply by something that will help you cancel the x out or the y out. Okay, and this does take a little bit of practice, so if you need some further support, just come and see me and I'll help you out. Okay. Anyway, So right here, since we already did step number 1, now we're at step number 2, which is the adding part. So here, I see that my x's cancel out. Negative 21 plus 5 is negative 16y, okay? And then now we have 48 plus 16, so just like regular addition, 8 plus 6 is 14, carry the 1, 4, 5, 6. So this is 64, okay? And now I can do step number 3, which is to solve. So I'm going to solve for y. So I'm going to divide by negative 16 on both sides to get y by itself. So y is equal to 64 divided by negative 16. That is negative 4. If you can't do that in your head, that's perfectly fine. You can use the calculator for that. So now that I have one of the answers, I can do my last step, which is step number 4, which is to find the other variable. Okay. So I'll use the second one, just, change it up a bit. Negative 9x plus 5y is equal to 16. And I'm going to substitute my y value. So this y value is going to go right here where the y is. So negative 9x plus 5 times negative 4, because that's my y, is equal to 16. And here we just simplify. So negative 9x, 5 times negative 4 is negative 20. So minus 20 is equal to 16. I'm solving for x, which means I have to get x by itself. So I'm going to do plus 20, do your line, plus 20, okay? Bring everything down, so negative 9x is equal to 16 plus 20 is 36. And my last step here is to divide everything by negative 9, which gets rid of it over here because that's just 1. So x is equal to 36 divided by negative 9 is negative 4. And we're pretty much done. So my solution for this system of equations, okay, is that x equals negative 4. Remember, we start with x, and y equals negative 4. So in this case, they're both the same number, which, happens sometimes. And this, again, represents where the two lines intersect, where they cross, where they share the same values. And that's it. So if you have further questions, come see me. Remember, this is just another method. You can also use substitution, but for the sake of not rewriting, this is a really good method.